Okay, in this section, we're kind of getting into what we would call transformations. In geometry, you did transformations where you shifted things and you reflected them, and we do the same thing in algebra. We take something like a simple function. For instance, we take a parent function is what it's called, and it's the simplest function of a certain type. And for the ones that we're studying, it's going to be y equal x squared. This is the simplest function of a quadratic form. Remember, quadratic equations are parabolas. And this y equal x squared, it has a vertex of 0, 0, and it has points like 1, 1, 2, 4, negative 1, 1, negative 2, 4 on it. You could graph it by just making a quick little table and just putting some simple values in it. Well, once you graph it, then once you know how to do that, you can use these transformations to graph harder functions more easily. Because in this, if we take this function and then we look at a function and we can write it in a form that looks like this, what ends up happening in this form, we have h and k. Well, now h and k are going to be our new vertex, but they also stand for horizontal and vertical shifts, just like they did in geometry. We had those shifts. The h is the horizontal shift, and the k is the vertical shift. If you remember just from class, this is just a brief summary. And then there's a number out front, and it's called a, and this tells us whether our parabola is going to be wider or narrower than our original parent function. Remember, this is our parent function over here. So this number a, if it's a fraction, our graph, if it's a fraction between, and I'll just put, I'll call the fraction a, it's between 0 and 1, it's going to be wider. And how I remember that, it's a fat fraction. It makes our graph wider than the parent function because it's climbing more slowly, so it takes longer to go up, and you end up with a wider graph. If a is, if the absolute value of a, and what we're saying is we don't care whether it's negative or positive, but if it's bigger than 1, then it is a narrower graph. And a big number basically makes a skinny graph. So one thing I would used to say to help me remember this, and that I told students that seemed to help them, was big is the new skinny. We're always hearing this is the new whatever, so big is the new skinny. Okay, and if that a is negative, we talked about what the number itself was, but if a is positive, the graph opens up like that. And if a is negative, it reflects the graph down and it opens downward like that. So that's what we're going to see in these problems. Let's do a few now. We look at number 7 and number 11 on this video. Y plus 2 equal x minus 1 squared. They want us to label the vertex, they want the axis of symmetry, and they want the intercepts. And we could check this using our calculator. When they want the intercepts, they want the x-intercepts and they want the y-intercepts. Okay. So what I've done, and remember you can pause your video if you need to be writing any of this on your paper. What I've done is I've labeled it vertex. This is called the vertex form right here. What I wrote in red. That's the name of this. And I can find, when it asks, what's so cool about this is if it asks me for the vertex, I can find that really easily because it's the h and the k in the equation. Well, now you've got a subtraction sign, so you've got to be careful here. Here's your x, here's your subtraction sign. Your h is actually equal to 1. So your vertex is hk. I can see my k value is equal to 1. I mean, my h value is equal to 1, not my k. Ignore that for just a minute. That was, I wrote it in the wrong spot. Now over here I got to be careful because here's my y, but I've got a minus sign and I got a plus sign here. So let's do this. Let's change that plus sign into a minus. Okay, so here's my y, here's my subtraction sign. What is my k? It is minus 2, so my k is minus or negative 2. So how you have to kind of look at this is because of the subtraction signs in the formula, you know how I had y plus 2 is x minus 1 squared? You look at it and you take the opposite sign of what it looks like. That's one way people do it. For instance, people might look at that and say, oh, my h is minus 1, but it's the opposite of what it looks. It's a plus 1 because of the subtraction sign in the formula. And they might look over here and they might say, oh, my k is plus 2. But no, it's the opposite of the way it looks. It's not a plus 2, it's actually a minus 2 because of that subtraction sign in that formula. So you can either change them over like I did when I was writing up in green above, or you can just remember that it's the opposite of the way it looks because there's a subtraction sign in the formula. A lot of people just do it that second way so they don't have to go rewrite everything. You just do what makes sense to your brain, okay? Now, do you remember that the axis of symmetry goes through the x-coordinate of the vertex? When we studied vertexes and axes of symmetry in Algebra 1, we knew there was a formula for the vertex and the axis of symmetry, and it's x equal negative b over 2a. Now that formula goes from when we have something in standard form. We don't have it in standard form here, so we're not going to do that here. But what that does help me to remember is this h right here, this x-coordinate of the vertex, it is the value I need for my axis of symmetry, because the axis of symmetry is a vertical line that goes through that x-coordinate. Well, a vertical line is always x equal, and so it's going to go through the x-coordinate, so is x equal 1. That's my axis of symmetry. I didn't have to go pull numbers off and stick them in a formula to find it. Now, as far as my x-intercepts and my y-intercepts were easy to find when we had them in standard form because they were the number on the end, but that's not what I have here. I have vertex form, so I can't use that same technique. So what I'm going to do is I'm going to go back and use this formula that I've got right here, this equation, the original equation, and to find the x-intercept, I'm going to set y equal to 0, because do you remember to find an intercept, you set the opposite value equal to 0? And to find my y-intercept, I'll go set x equal to 0. So I've got several things to do here. Let's get started. Let's find our x-intercepts first. And usually, by the way, there's usually 2 of them, though there are sometimes none. But usually there's 2. Let's see what happens here. I've got the equation y plus 2 equal x minus 1 squared. But what I want to do is I want to set y equal to 0. So that's over here, okay? So let me just put a 0 over the y to plug it in. Now 0 plus 2 on that side will be 2. The only reason I did that is I'm running out of space and I'm trying to fit at least this part on this page here. So I have 2 is equal to x minus 1 squared. Now how am I going to solve that? We've been talking about all the different ways we could solve quadratic or square equations. If you look at this one, wouldn't it be real easy to square root both sides to find this? Square root of x minus 1 squared is just x minus 1. It's just what's under the radical. And because I wrote that square root, I need a plus or minus there, and it's the square root of 2. So if I want to solve for x, I'll need to add 1 to both sides. So what is x? These are my x-intercepts, remember, because I set y equal to 0. The x is 1 plus or minus square root of 2. Now that's 2 x-intercepts. One of them is 1 plus square root of 2, and one is 1 minus square root of 2. But you know, lazy mathematicians, if they can get away with writing it together, they're going to. So that's why they're going to use that plus or minus there. So there's 2 of them, but I can write it as 1 plus or minus the square root of 2. That's the x-coordinate. And what is the y? Well, didn't I set y equal to 0 over here? I'm going over it in black now. Y is 0. To find my y-intercept, I'm going to set x as 0. Let me go ahead and put it there just so I don't have to worry about it at the end in case I get kind of confused. Let me go to the next page to find the y-intercept. We need to set x equal to 0. So I've just copied that down here. So now we're going to go in and set x equal to 0. This time I'll plug it in all proper. Okay, so x is equal to 0. Plug it in, minus 1 squared. So I have y plus 2 equal 0 minus 1 is a negative 1, but I'm going to square it. Y plus 2 is equal to 1. Oh, to solve for y, all I got to do is subtract 2 from each side. Y equal negative 1. Oh, there we go. There's my y-intercept. So we found our x-intercepts, our y-intercepts, our vertex, and our axis of symmetry. We've done all those parts on number 7.